questions, but I would just invite Carsten Strampe then.
Okay, thank you.
You will give us 7 tips to create an embedded vision system, if I hear it right? Correct. Perfect. Let's go.
There you go.
The general manager of IMAGO Technologies, and I'm a little bit crazy because since 3 decades I'm working in the machine vision sector. So, and I survived. Always new ideas. It's a fantastic professional life. 7 tips to create an embedded vision system, and some words to IMAGO Technologies. Your software needs to run on a hardware, a piece of hardware, a specific piece of hardware. So our intention is to provide the best hardware solution for your machine, for your device. The company IMAGO Technology was founded by myself some years ago in 1994, a former company. And at that time, we were working as a system integrator for machine vision. And in 1998, we introduced at the Vision Show here in Stuttgart our first embedded vision computer specialized for machine vision. And in the meantime, it's a big family of vision computer and smart cameras. And more than 20,000 of these vision boxes are working in machines worldwide. Today we are a team of 25 people. So even we produce serious products, we are flexible and innovative, still a compact team. Regarding our portfolio, very popular, our vision computer called Vision Box. And here the color of the label defines different type of CPUs inside. So from Intel x86 multi-core ARM up to date today, the combination of a CPU and GPU. And if it looks like a camera, for us it's still a vision computer. A smart camera, the basic is a Linux vision computer inside, multi-core CPUs. And if it becomes smaller, we call it vision sensor. So that is our portfolio. Coming to embedded vision. What does it mean for machine vision? So embedded vision has many sectors, especially in machine vision. First of all, we want to embed the system into the machine infrastructure, a kind of optimization level. We optimize not only the camera interfaces or some specific computer infrastructure, also machine interfaces, some protocols, the control of the illumination, the camera peripherals. So everything is optimized for a specific application in a machine or in a device. And this optimization is for your application, and this is a different approach. If I invent a smart camera for the world market, I have a general approach and I need to look for specific application. I hope my smart camera will solve that application. In contradiction, we speak with you, we adjust the requirements, and then we provide the optimized embedded vision approach. And also we take care about the power consumption and the requirements of your specific application. Now I start with tip number 1 to 7. These are more general tips. Probably you are the experts, but first of all, we want to generalize some tips. Starting with tip number 1. The hardware development of an embedded vision system isn't isn't easy. But using it today, in the meantime, is very easy. So the tip is, how do you start? Are you starting with an evaluation board from a CPU vendor? And what are the steps between an evaluation board and industrial product? So there are many steps between these two situations. You need a specific electronic board. You need the infrastructure of the electronic board, the firmware support of the OS. You need an industrial design regarding everything from the housing, interfaces, mounting. And you need a software development kit to start with your specific application. So that is in the different, and sorry for that example, it's coming from IMAGO, but please take a look into the market. There are many different solutions, many different ideas. Compare it between a basic electronic board for the laboratory and a professional industrial device. The next step is who has the IP, the intellectual property, and also some questions maybe regarding experience in the operating system, maybe if you have to port some code from Windows to Linux, who has some experience, who can help you. Another step is the software infrastructure. It's not only the hardware, the software infrastructure to help you to start as much as easy with the application development. So there are tools in the market optimized for an embedded system. And here we see an example of a web browser tool together running on the camera, where you can focus on your specific application. And that tool provides, for instance, the image acquisition, digital input, output, very important, the web-based GUI already available, and protocols like OPC UA, RESTful interface, and practical details. And the core, the image processing, that is our approach. That is up to you, because you have a specific application. You can use the Haken library, you can use your own, you can integrate your own C++ code, Python, or TensorFlow Lite approaches. And that is the idea, an easy start, and to focus on the application. Tip number 2. Maybe in the market you see a lot of embedded vision systems for code reading. That is not the real world. Today, many different applications are already embedded into machines. So don't be shy to have some fantasy, to ask for specific ideas. For instance, we realized high-speed application, or we have a complex scene analyzed by an embedded vision system. We integrated already AI functionality into the smart camera, and we integrated prophecies, event-based sensor, and also some other markets, they expect from an embedded vision system that you provide quantities of 10,000, 100,000 units per year. No, in machine vision can be less than 1,000. But I think regarding the overall effort, it must be clear you need some numbers, some serious numbers. Typically in machine vision, you need the long-term availability of at least 5, sometimes 10 years. With the next tip, we are coming to the situation inside of the cabinet. And today, some machine builder, they do advertisement and say, my machine does not need any more a cabinet for all the controls, etc. So a cabinet-free automation system. Often space is a limited factor. Therefore, components need to be very compact. Inside of the cabinet, everyone wants to save space in the cabinet. The next topic is the climate control. So the more power you need for your vision system, maybe at the next level, the climate, you need a climate control unit for the cabinet to take out all the heat. The cabling from and to the vision system is important because an embedded vision system has a small infrastructure and makes the computing inside of the system. So you need less cables to the cabinet. Finally, today we have embedded vision systems. They are small, like a matchbox. Everything inside, multi-core, CPU, the sensor, of course, interfaces. So this is the reflection regarding the components, the overall components, from the camera, cabling, vision computer, maybe the climate control. So very important in this time. The next tip is more commercial. It helps you saving money. In this time, prices are increasing, so engineers are obliged to create ideas saving money. Per functionality, embedded vision are lower cost per unit. We have lower cost for the cabling, not even the cables itself, also the people doing all the cabling. Very important from the technical point of view, lower cost of debugging. You have a smaller unit, less functionality, and if there is an error, it's easier to debug the smaller device than a big industrial PC running many cameras, running too many programs. And lower cost of validation. If you have to validate the system, for instance, in the pharmaceutical industry, the embedded vision system, it's easier to have the validation process. The next tip comes to our environment. Yes, embedded vision helps you save energy and resources. Maybe that today it becomes more and more important. So first of all, we have less energy consumption with Linux. You know it from your smartphones. Maybe you remember some older generations of smartphones using something like x86 and the Windows operating system on the smartphone. Time is over. In embedded, normally you run the Linux operating system and the infrastructure needs less energy. Then the next point is the efficiency of the software, the overhead of software. Start your laptop and take a look how many tasks are running. You are doing nothing. Take a look how many tasks are already running on your laptop only to boot the computer. So it's more easier in an embedded vision system. It needs less memory. It needs less CPU power. Saving energy is a competitive advantage. Maybe your sales colleagues are happy because they can bring that value to the customer. The next slide is, yes, a software engineer, maybe changing from Windows to Linux can become a topic. Often we have that discussion because IMAGO also sells standard vision boxes with the Windows operating system. So we have experience with customers using Windows, customers switching from Windows to Linux. Other ones have Linux experience. But some people are afraid moving from the Windows operating system to Linux. So deep Linux knowledge is not required anymore regarding the support of additional tools and the focus on image processing. The tools, they provide the infrastructure, so you need less resources to develop a Linux-based vision system. Then the Windows operating system that offers a lot of tools you do not need. The difference between Windows and Linux is with the Windows, you get a whole infrastructure of Windows with many tools. And to compare that with Linux, there you are free to install only programs and tools necessary for your application. So the system becomes more easy, more slim. That is an advantage of the Linux OS. Regarding the porting from Windows to Linux, we have some experience on that because we helped our customer to bring a Windows system on the Linux. So we have some tips and tricks. It's not so complex to bring a standard Windows system on a Linux computer. And finally, less complexity, less chance for an error. Last one, tip number 7. Embedded vision, a growing market, but not in machine vision. Because the experience is regarding quantities of technologies, CPUs, whatever, machine vision is a very, very small market. We have other mass markets, for instance, we have the autonomous driving, we have 5G, we have Internet of Things. These markets drive the development of CPUs, of GPUs, etc. And we have the chance to take these technologies and use it in machine vision. But we have to look into these other mass markets. AI goes embedded. In the meantime, we can integrate AI functionally in a small form factor of a smart camera. That is feasible. We do not need any more big GPU cards. That is already available in the market. And finally, it increases the attractiveness for customers using these components. My last slide, the next steps. IMAGO, we can provide with many questions our experience. We have a portfolio of embedded vision components from specific vision boxes up to smart cameras. We have infrastructure regarding the software support so that you can focus on your application. And of course, we offer also engineering service to speed up your development. So, thank you for your participation. Thank you for your patience. We are here in the hall number C26 for further discussions and your questions. Thank you.
Thank you so much for the presentations. Please give a round of applause to all of my speakers. I have some questions, but I will take it offline.
Okay.
I have seen something that is in my area of expertise, if I may say so. So thank you once again.
Okay.
And I
Good
say
afternoon.
bye for this vision. Maybe next vision we see each other again.